Hello and welcome back to this video series regarding the Intermediate Math League of Eastern Massachusetts. Today we're going to be starting up the Arithmetic section for Meet 5, talking about Combinatorics. So let's get right into it. So all of Arithmetic Meet 5 is about either Combinatorics or probability. And today, as I said, we're going to talk about that first one, Combinatorics, which are questions that assess how many possible combinations of something there are. So some examples of combinatorics in daily life are orders at an ice cream shop, how many different orders you could make, for example, or passwords, like how many different passwords you could have on an iPhone or on a keypad or a garage code. Those are all examples of combinatorics because it's how many different combinations of something you can have. Now, there are two types of combinatorics which we're going to look into, and the first one is called permutations. So permutation questions for combinatorics are ones where the order of the options matter. So let me give an example question. This question says, John gets to use the digits 5, 4, 3, 2, and 1 to make a 5-digit number. He can only use each digit once. How many possible 5-digit numbers can he make? So this is a permutation question for combinatorics because, first of all, it's asking you how many different possible numbers he can make. So it's asking you about the combinations of those numbers. Now, the reason it's a permutation is because the order in which he places the numbers matter. For example, if he uses all 5 numbers, the number he makes is going to be different if he starts with 5, for example, if I had 5, 4, 3, 2, 1, than if he starts with 1. For example, if I had 1, 2, 3, 4, 5. Now, at first, it may seem a little bit simple just to write out all the possible numbers he can make, but that's going to take a really long time. And it's really easy to get confused and get a little bit disorganized with that work. So we need to solve this mathematically. And this is what we're going to focus on in today's lesson. When we get to combinatorics questions, the main thing we want to think about, whenever we're doing a question, is choices. How many different possible choices can you make when making different combinations? So let's look at the choices John can make. If he has the digits 5, 4, 3, 2, and 1, and he needs to make a 5-digit number, well, he has 5 digits that he can use for the first digit of this number. So for the first digit of this number, he can make 5 different choices. Now, after he writes the first digit of whatever this number is, he'll have 4 numbers left that he can use. So say he chooses 3 as his first number. Well, now he can't use 3 anymore, but he has 4 other possible numbers. And the same applies if he didn't choose 3. If he chose 2, then he wouldn't have 2 anymore, and he would have 3 in the rest of the numbers. So he starts with 5 options, and now he has 4 options. And then after he chooses his second number, now he only has 3 options left. And he can probably see the pattern until he has 2 options, and then at the end, he has 1 option left for his 5th digit. So you multiply this out, and this gets you to 120. He has 120 possible 5-digit numbers that he can make. And what we just did is called using factorials. So this is really important that you know what this means because this is going to show up a lot in the combinatorics section. A factorial is a number multiplied by all natural numbers less than it. And the way that we write factorials is with an exclamation point. So for example, 6 factorial means 6 times 5 times 4 times 3 times 2 times 1. And it's pretty simple. And for example, 10 factorial, like this, would be equal to 10 times 9 times 8, and then all the way down to times 2 times 1. And so as long as you know what factorials are, it'll make it a whole lot easier to do these questions. All right, so the question that I put on the last slide is a relatively easy permutation question. But a lot of the permutation questions you're going to get in combinatorics are going to be a little bit more difficult than that one. So now we're going to look at those types of questions and see if we can derive a formula to use for any permutation question. And remember, permutation ones are the ones where the order of the choices matter. So here's an example of one of those more difficult questions. It says 6 students enter math competition. There is prize money awarded at the end as follows: $100 for first, $50 for second, and $25 for third. The students who place 4th through 6th will not receive any prize money. How many possible ways are there for the prize money to be awarded? Now, the reason that this is a more difficult question is because we can't just do what we did last time. So, right, we have 6, and I'll show you why. We have 6 students, so you might think, okay, well, there are 6 possible students who can come in first, and then imagining one comes in first, there are 5 possible students left who can come in second, and so on, and you could just do 6 factorial to get the total number of combinations of students in different place orders, right? And this would get you to 720. However, the reason that you can't just do this is because it's asking how many possible ways there are for the prize money to be awarded. So for example, if I label the students A through F, so I have students A through F, let's say student D came in first, and then E came in second, and then F came in third, A came in fourth, B came in fifth, and C came in last, right? Then D would get $100, E would get $50, and F would get $25. And that's one possible combination of how the prize money can be awarded. Now, if we come up with a different combination of the students in order, so for example, D, E, F, B, C, A, then in this case, D would get the $100, E would get 50, and F would get 25. And that's the exact problem. You'll notice that the prize money was awarded the exact same way to the students in both of these scenarios, even though that the students placed differently. Because the people in the last 3 spots, so these 3 spots, they don't get any prize money. So it doesn't matter what order they came in. All we care about is who comes in first through third, which is why we can't just do this, because this has too many possible combinations taken into account. So what we need to do then is we need to figure out to find a way to not include the combinations, or only include one combination where we have, only include the combinations for the top 3. And the way that we do that is that we drop these 3 numbers when multiplying. Because if you think about it this way, we have 6 students who can come in first. And after one of those students has come in first, we can have 5 students who come in second. And after one of those students has come in second, there are 4 possible students left who can come in third. And then after that, we don't care who comes in 4th, 5th, and 6th. So we don't need to keep multiplying. So all we need to do is stop here, right? Because now there are too many people, or there are too many people that it doesn't matter who comes in the rest of the places. So we do 6 times 5 times 4, and this gets us to 120, I believe. And I am just going to quickly do that in my calculator just to make sure that that's not incorrect. 6 times 5 times 4, yes. So 120 different possible combinations. So now if we're going to try to write a formula for this, well, let's imagine n is the total amount of choices you have. So in this case, n represents the 6 students. So n would be 6. And k, this is a new variable, is how many you have to choose, or how many you care about for the order, right? So in this case, we cared about the top 3 students, but we didn't care about the last 3. So k in this case would be 3. Then our formula would be n factorial, right? Because we took 6 times 5 times 4 times 3 times 2 times 1, and then divided by n minus k factorial. Because we're taking away whichever's the amount of students that we don't care about. So for example, if k was 2 and we only cared about the top 2 students, then n minus k would be 6 minus 2, and that would get us to 4. And then if we're to do the multiplication out, we would just do 6 times 5, which is why if we actually write this out, let's imagine we only cared about the top 2 students, and n minus k was 4, then n minus k factorial would be 4 times 3 times 2 times 1. And if you write this out, here's why it makes sense. Imagining we had 6 times 5 times 4 times 3 times 2 times 1 in the numerator, and then divided by 4 times 3 times 2 times 1 in the denominator. Then this 4, the 3, the 2, and the 1 all cancel, and we're left with 6 times 5, which is exactly what we need to do. And if k was 3, then n minus k would be 3 factorial. And then instead of having 4 times 3 times 2 times 1, we'd only have 3 times 2 times 1 in the denominator. And this 4 wouldn't cancel, and just like we solved this question, we do 6 times 5 times 4. So if you want me to write out the formula here in text, then here's the formula. And now we're going to move on. All right, so now I have a review question about permutations. If you'd like to try it, I'll give you a few seconds to pause the video, and then I'll explain the answer. All right, so the correct answer to this question was 2,520, which is a huge number, but let's go through the question. It says, at the start of the year, a teacher buys 1 copy of each of 5 DVDs: Star Wars, Star Trek, Harry Potter, Toy Story, and Shrek, and announces that at the end of the year, she will give them out as prizes to students with the best attendance. At the end of the year, 7 students have perfect attendance. How many possible ways is there for the teacher to give the DVDs out? And I realize that it says at the end of the year many times, so I'll just cross it out here. All right, so this is a permutation question because the ways that she gives the DVDs out does matter, right? Because they're not all the same DVDs. For example, if I had 2 students, students A and students B, I mean, she could give both of them DVDs, but it would be different combinations if she gave 1 Shrek and 1 Toy Story than if she gave the first one Toy Story and the second one Shrek. So that's why this is a permutation question, meaning that we can use our permutation formula to solve it. So remember, n is the total number of choices. So total number of choices, and I'll just write CH for short. And then k is going to be the choices that we care about, right? So the choices where it matters what order they're in or who's given what. So k is choices we care about. And our formula for this then is n factorial, the total number of choices factorial, divided by n minus k factorial. So now let's figure out what our n and k are for this question. So it says, at the start of the year, a teacher buys 1 copy of each of 5 DVDs. And you have to be careful here. N is not 5, because the DVDs are what's being given out to students. So the amount of students that we have to choose from, that's going to be our n. And in the last sentence, it says, at the end of the year, 7 students have a perfect attendance, meaning that for this question, n equals 7. Now, since there are only 5 DVDs, that means that for the 2 students who don't get DVDs, it doesn't matter whether or not student B didn't get a DVD and then student C rather than student C and then student B, right? So we only care about 5 students total. The other 2 don't matter because only 5 of them are going to get DVDs, meaning that our K for this question, K, is going to be 5. So now if we put this in our formula, we get 7 factorial, which is 7 times 6 times 5 times 4 times 3 times 2 times 1 divided by n minus k factorial. And 7 minus 5, or n minus k, is 2. So if we divide this by 2 factorial, we do divided by 2 times 1. Now this 2 and this 1 cancel. So for our final answer, we do 7 times 6 times 5 times 4 times 3. And remember, you do get a calculator for this. So when you do that out, we get 2,520 possible combinations. And again, the reason that this works is because we're only considering the students that we care about who gets DVDs, right? We only care about the 5 students who get DVDs, and the other 2 students really don't matter, which is why we have 7 to choose from, then 6, then 5, then 4, and then 3. And then it doesn't matter who we choose next because they're not getting a DVD anyway. So that's why we end up with this formula at the end. All right, so I said that there are two main types of combinatoric questions, and the other one is combination questions. So we had permutations where the order did matter. Now we have combinations where the order does not matter. So let me give an example of a question. Now this is similar to a question that we saw earlier that I gave as a permutation question, but now it's a combination question because of one key difference. It says students enter a math competition. There's $25 in prize money awarded at the end to the top 3 students. The students placing 4th through 6th do not receive any prizes. How many different groups of students can possibly receive prize money? All right, so the reason that this one is different than the last one is because if you remember from the last one, it gave $100 to the first student, $50 to the second one, and $25 to the third. But now it just gives $25 to all 3 students in the top 3, and still the students placing 4th through 6th don't receive any prizes. So if it said how many different ways can the prize money be awarded, like it does at the end here, then it doesn't matter, like among the 1st through 3rd students, it doesn't matter who came in which place, they're all getting the same amount of money, which means if student A came in 1st, student B came in 2nd, and student C came in 3rd, they would all get $25. And likewise, if student C came in 1st, A came in 2nd, and B came in 3rd, they would also all get $25. And so it doesn't matter what order you put them in, they all get $25 anyway, which is why now this is a combination question, because the order doesn't matter. So now we're going to try to derive a formula to figure out how many different possible combinations there are. So we're going to start with our permutation formula, where we had n factorial over n minus k factorial. Because again, we only care about how many possible combinations there are for students in the top 3, right? So it doesn't matter who comes in 4th, 5th, or 6th. So we have 6 possible students who can be in 1st, then 5 possible students who can be in 2nd, and then 4 possible students who can be in 3rd. And 6 times 5 times 4 equals 120 possible combinations for the top 3 students. And that's what we get from this formula, because we do 6 times 5 times 4 times 3 times 2 times 1 in the numerator divided by 3 times 2 times 1 in the denominator. And then we end up with this. Now we can't stop here, because remember, we have 120 possible combinations for the top 3, but it doesn't matter the order of those top 3. So among these combinations, we have things like student A in 1st, B in 2nd, and C in 3rd. But then we also have B in 1st, A in 2nd, and C in 3rd. And we have C in 1st, A in 2nd, and B in 3rd. And you can see where I'm going with this. So now we need to figure out a way to eliminate it down to just how many different possible combinations of students there can be in the top 3 based off which students are in the top 3 and not which students are in each place. And for that, what we need to do is divide by k factorial again, because we care about how many students are in the top 3, right? So now we have how many students there can possibly be in the top 3. And among those students in the top 3, there are 3 possible students who can come in 1st, 2 who can come in 2nd, and 1 who can come in 3rd, which means 3 times 2 times 1, or 6, is the amount of combinations you can have among 3 students who are in those top 3 for what order they're in. So we only care about how many there are or who's in the top 3, not what order they're in. So therefore, if we divide this 6 times 5 times 4, the 120, by 6, then we get 20 possible combinations of students who are in the top 3. And so that's why we put k factorial also in the denominator next to this. So your final formula will be n factorial divided by k factorial times n minus k factorial, where you have to do both of these and divide by both of these. All right, so now I have a review question about combination questions for combinatorics. If you'd like to try it, I'll give you a few seconds to pause the video and then I'll explain the answer. All right, and finally, we're just going to talk about other types of combinatorics questions. I know I said that there are 2 main ones, and that's because permutations and combinations are the 2 main ones. But there are a few types of other ones, but they're a lot easier to do, which is why I'm just including them all on this slide. And the first is choice without replacement, which is when options don't get eliminated after being chosen. So the difference between this type of question and the other ones is, say you were picking people from a group, after you choose someone, you can't choose them again. But in this example, where you say how many different 4-digit passwords can be made out of the numbers 0 through 9, you can choose the number 8, for example, for your first digit, but then it's not like you can't choose 8 for the rest of them. You can. So that's why it's choice without replacement, because you're not eliminating anything after you choose it once. So that's what makes this question so easy, actually, is that you just say, well, we have 10 possible numbers that I can choose for my first one, and then 10 for my second, 10 for my third, and 10 for my fourth. And so you just end up with 10 to the power of 4. And so if you really wanted a formula for this, then it would be 10, or not 10, it would be n, which is how many choices we have to the power of, and I'll call this number t. How many different times you're choosing out of those numbers. So we are choosing out of those numbers 4 times for a 4-digit password. So therefore we get 10 to the power of 4. And if you don't believe me, this equals 10,000. And if you think about it, the lowest number you can have is 0, 0, 0, 0. And you can have the highest number of 9,999, which means that you have all the numbers in between, and that totals to 10,000 possible numbers. All right, the second type of one that we have that's also really easy is yes or no group questions. And these seem really hard at first, but I'll just explain why it's actually not that difficult. So this is like a combination question, except the size of the group isn't specified. So an example of this is a teacher has 8 students in the class, and she needs to send at least 1 student down to the office to pick something up for her. How many ways can she choose a group of students to go down to the office? So the reason that this is similar to a combination question is because she's choosing students to go to the office, and it doesn't matter what order they're chosen in, except the difference is we don't know how many students she's sending. That actually makes the question easier. And the reason why is because you can think of each student of having a choice of whether they're going to go or not, right? So student A can either be in or they're out. And so they're either a yes or a no. And there are 2 possible combinations for student A. They're either in or they're either out. For student B, they can also be either in or out. For student C, they can be in or they can be out. And every single student is either going to be in or they're going to be out, which means that they have 2 choices total. So we have 8 students, and each has 2 possible options. So therefore we do 2 times 2 times 2 times 2 times 2 options times 2 options times 2 options, and then times 2 options for each of the 8 students. And therefore we get 2 to the power of 8. So the way that we do this question then, when you have this unspecified group size, is you say, and I'll call this number C for how many choices each student has, right? In this case, we had 2 choices per student. They were either in or they were out, to the power of how many students there are, which I'll call n. So C to the power of n, or 2 to the power of 8, gets us to 100 or 256. All right, and finally, I have this review question about those other types of combinatoric questions. If you'd like to try it, I'll give you a few seconds to pause the video, and then I'll explain the answer. So the correct answer to this question was 128. So let's read the question. It says, Caroline invites 7 friends to go shopping with her at the mall. All of the friends respond with whether or not they can make it. How many possible groups of Caroline's friends could go to the mall with her? All right, so this is one of our yes-no type of questions, right? We have an unspecified group size out of a total group. So you might be thinking, okay, well, I'll just use the formula. It's going to be C to the power of n, where C is the amount of choices that someone has, and n is the total amount of people. That's, yes, you do use this formula, but you have to be careful about what you make your n. Caroline is inviting 7 friends to go shopping with her. That means that there are 8 people total. So you might think that n is going to be equal to 8, but n is not equal to 8. And the reason why is because n is going to be the amount of people who actually have to make that choice. Caroline is one of those people, one of those 8 people, but she's guaranteed to go. Her choice is definitely a yes. So every single group is going to include Caroline, which means that there are only 7 people who are making choices. So n is going to be equal to 7. And if you got that right away, then just, yeah, you can continue on. So n is 7, and c is the amount of choices that each person has. Now, each person can either be in or they can be out, which means they have 2 choices. So therefore, we do 2 to the power of 7, and that gets us to 128 possible groups. All right, and just to quickly review what we've learned this lesson, we talked about combinatorics questions, which are questions that assess how many possible combinations of something there are. And we talked about permutations first, which is when the order of the options that you have matter. So an example is if you're making 5-digit numbers out of certain digits, but you can't use a digit more than once, then the order which you put them in matters. And then we figured out what factorials are for this question, which is when, say you had 6 factorial, then you would take that number and multiply by all natural numbers less than it. Then we talked about harder permutation questions where we derived this formula, n factorial over n minus k factorial, where n is the amount of choices and k is the amount of choices we care about to determine that permutation. Next we did a review question with permutations, and we got the answers 2,520. Then we talked about combination questions, the other main type of combinatoric, and that's where the order of your choices does not matter, unlike permutations. And from this, we derived a formula similar to the permutation one, where we had n factorial divided by n minus k factorial times k factorial, where k factorial is also in the denominator, in order to figure out our total combinations. And then we did a review question where we found that there are 56 possible groups of 5 astronauts. And finally, we just looked at 2 other types of combinatorics questions that didn't really fit those other categories, but they were pretty simple. We had choice without replacement and yes or no group questions, and most of these were just intuitive. And then we did a yes or no group question as our final review question and got 128 groups. All right, so that's all I have for today's lesson. I hope it is helpful, and I'll see you next time.